and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is the first lesson on algebraic long division, and to introduce this concept I'm going to start off just by talking about what a factor is, and to illustrate that I've just gone with a quadratic x squared minus 3x minus 10 equals 0, and your first thought when you see something like this is probably to factorise it to x minus 5, x plus 2 equals 0. And let's just have a think about what that means. It means that x minus 5, x plus 2 are factors, because they both divide into this with no remainder. From here, what you most likely would want to do is you would want to say that x equals 5 and x equals negative 2 from those two brackets. Well, they are the solutions to the equation. Fine, so far so normal. But what does that actually mean, that they're solutions? Well, what it actually means is that if you substitute those numbers into this equation, it satisfies it and you end up with 0. So it means that f of 5 equals 0 and also that f of negative 2 equals 0, just using the notation for functions here, so meaning I'm substituting 5 into this function here. And all this language of what is a factor, what is a solution, and all of this comes into this topic an awful lot with algebraic long division. I'm just going to begin by showing a numerical example of long division, and we're going to do 3,528 divided by 9. Now, generally how students want to do this is to set it up like this into a bus stop, and the first thing they do is they say, right, 9's into 3 goes 0, remainder 3, so now I've got 35. Fine, but I just want to show you a slightly different way of doing that, thinking about where that 3 actually comes from. Well, it comes from the fact that 0 times 9 is 0, and 3 is what we've got left as a remainder. This 5 then comes down, so now we're doing 9 into 35. So not only is it clearer than trying to squeeze that number in there, this is exactly the process we're going to use when we come to do this with algebra. 9's into 35 goes 3. 3 times 9 is 27, which is a remainder of 8. And bring down the 2. 9's into 82 goes 9. 9 times 9 is 81, remainder 1, bring down the 8, and 9's into 18 gives 2. 2 times 9 is 18, which means there is no remainder, and that 9 divides exactly into 3,528, and the answer is 392. Now, how do we apply this to algebra? Well, we've established that x minus 5 is a factor of x squared minus 3x minus 10. So if I was applying this method to divide this quadratic by this linear term, I would start off by saying, how many times does x go into x squared? Well, it's x, because x times x is x squared. When I multiply back, like I did here, to do 3 times 9 and got 27, I do x times x minus 5, and I get x squared minus 5x. And I find the remainder by subtracting. X squared take x squared is nothing. Careful with the signs here. Negative 3x, take away negative 5x. So taking away a negative, we're adding 5x to negative 3x, which is going to give us 2x, and then bring down the negative 10. And you might already be seeing what's about to happen. X into 2x goes 2. And then when you multiply back by the 2, 2x minus 10, and because you're doing something take away itself, we have no remainder, which means that when you do x squared minus 3x minus 10 divided by x minus 5, you get exactly x plus 2 with no remainder, which we knew before. In the next video, we'll look at how to divide more complicated expressions by a linear term. I'll see you then.